Yes, the sheet metal of a pole building constructed with wood framing members requires bonding. According to the National Electrical Code, all metal parts of a building's electrical system must be bonded together to create a low-resistance path for electrical current to flow in the event of a fault. This includes the sheet metal of the building, as well as any other metal components such as the framing members, conduit, and electrical boxes. Bonding the sheet metal helps to prevent electrical shock and fire hazards by ensuring that any stray electrical current is safely discharged into the ground. It also helps to protect the building's electrical system from damage by providing a path for current to flow in the event of a lightning strike or other electrical surge. The NEC requires that the sheet metal of a pole building be bonded together using a copper bonding strap or other approved bonding method. The bonding strap should be at least 1/4 inch wide and should be attached to the sheet metal at intervals not exceeding 6 feet. The bonding strap should also be connected to the building's electrical grounding system. Bonding is a critical safety measure in electrical installations. Its primary purpose is to create an electrically conductive path that allows fault current to flow back to the source, tripping the circuit breaker or fuse and energizing the circuit. This rapid energization minimizes the risk of electrical shock to people who might come into contact with the energized metal and reduces the potential for fire. In the context of a pole building with sheet metal cladding, several factors necessitate bonding. Firstly, sheet metal, while providing structural support and weather protection, can become energized due to various reasons such as a fault in the electrical wiring within the building, induced voltage from nearby power lines, or even lightning strikes. Without proper bonding, this energized sheet metal poses a significant electrical shock hazard. Secondly, the NEC mandates bonding of all metal parts that are likely to become energized. This requirement stems from the code's overarching goal of ensuring electrical safety and protecting people and property from electrical hazards. The NEC provides specific guidelines on how to achieve effective bonding. These guidelines typically involve the use of bonding conductors, such as copper wires or straps, to connect the metal parts together into the building's grounding system. The grounding system, in turn, provides a low impedance path for fault current to flow back to the source. When selecting bonding conductors, it is essential to consider their size and material. The NEC specifies minimum sizes for bonding conductors based on the size of the circuit they are intended to protect. Copper is the preferred material for bonding conductors due to its excellent conductivity and resistance to corrosion. The installation of bonding conductors should be done carefully and according to the NEC guidelines. The conductors should be securely attached to the metal parts using approved connectors, and they should be protected from physical damage. The connections should be clean and free of corrosion to ensure good electrical contact. In the case of a pole building with sheet metal cladding, the bonding conductors should be attached to the sheet metal at multiple points to ensure that the entire surface is effectively bonded. The spacing between the bonding points should be determined based on the size and configuration of the sheet metal panels. In addition to bonding the sheet metal, it is also essential to bond any other metal parts that are likely to become energized, such as metal framing members, conduit, and electrical boxes. These metal parts should be bonded together into the building's grounding system to create a comprehensive bonding network. Regular inspection and maintenance of the bonding system are crucial to ensure its continued effectiveness. The connections should be checked for tightness and corrosion, and the bonding conductors should be inspected for damage. Any issues that are identified should be addressed promptly to maintain the integrity of the bonding system. There are several methods that can be used to bond the sheet metal of a pole building. Firstly, using a copper bonding strap. A copper bonding strap is a flat strip of copper that is used to connect the sheet metal to the building's grounding system. The bonding strap should be at least 1/4 inch wide and should be attached to the sheet metal at intervals not exceeding 6 feet. Secondly, using a bonding wire. A bonding wire is a copper wire that is used to connect the sheet metal to the building's grounding system. The bonding wire should be at least number 6 AWG and should be attached to the sheet metal at intervals not exceeding 6 feet. Thirdly, using a bonding fastener. A bonding fastener is a screw or bolt that is used to connect the sheet metal to the building's grounding system. The bonding fastener should be made of corrosion-resistant material and should be tightened to the manufacturer's specifications. The importance of proper grounding and bonding cannot be overstated. It is a fundamental safety requirement that protects people and property from electrical hazards. By understanding the principles of grounding and bonding and following the NEC guidelines, electricians and building owners can ensure that electrical systems are installed and maintained safely. Always consult with a qualified electrician to ensure that the electrical system is properly grounded and bonded. A qualified electrician will be able to assess the specific needs of the building and recommend the appropriate grounding and bonding method. They will also be able to perform the installation and testing to ensure that the system meets the NEC requirements. Neglecting grounding and bonding can have serious consequences. It can increase the risk of electrical shock, fire, and equipment damage. It can also void warranties and lead to insurance claims being denied. Therefore, it is essential to prioritize grounding and bonding in all electrical installations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. The NEC is a complex document that covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is essential for electricians and other electrical professionals to have a thorough understanding of the NEC to ensure that they are installing and maintaining electrical systems safely and correctly. The NEC is divided into chapters, articles, and sections. Each chapter covers a specific area of electrical installations. For example, Chapter 3 covers wiring methods and materials, Chapter 4 covers equipment for general use, and Chapter 5 covers special occupancies. Each chapter is further divided into articles, which cover specific topics within the chapter. For example, Article 250 covers grounding and bonding, Article 300 covers wiring methods, and Article 400 covers flexible cords and cables. Each article is further divided into sections, which provide specific requirements for electrical installations. For example, Section 250.20 covers general requirements for grounding, Section 300.4 covers protection against physical damage, and Section 400.8 covers uses not permitted for flexible cords and cables. The NEC is not a set of instructions that can be followed blindly. It requires the electrician to exercise judgment and apply the code to the specific conditions of the installation. The electrician must consider the type of building, the occupancy, the voltage, and the available fault current when making decisions about the electrical installation. The NEC is a living document that is constantly being updated to reflect the latest advancements in electrical technology and safety practices. It is essential for electricians and other electrical professionals to stay up to date on the latest changes to the NEC to ensure that they are installing and maintaining electrical systems safely and correctly. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine the specific requirements for the area. Electrical inspections are an important part of the electrical safety process. They help to ensure that electrical installations are done safely and correctly. Electrical inspections are typically performed by local government agencies or by private inspection companies. The inspector will review the electrical plans and inspect the installation to ensure that it meets the requirements of the NEC and local codes. If the installation passes the inspection, the inspector will issue a certificate of compliance. This certificate is required to obtain a building permit or to connect the electrical system to the utility grid. If the installation fails the inspection, the inspector will issue a list of deficiencies that must be corrected before the certificate of compliance can be issued. It is important to correct the deficiencies promptly to avoid delays in the project and to ensure that the electrical system is safe. Electrical safety is everyone's responsibility. By understanding the principles of electrical safety and following the NEC guidelines, electricians, building owners, and homeowners can help to prevent electrical shocks, fires, and other electrical hazards. Always call a qualified electrician for any electrical work. Do not attempt to do electrical work yourself unless you are qualified to do so. This is especially true for pole buildings and their sheet metal. The bonding of the sheet metal is important due to ensure safety and prevent damage from electrical surge. In order to ensure a safe and compliant electrical system within your pole building, several key steps must be taken. Firstly, a thorough understanding of the NEC is paramount. This involves not only being familiar with the general requirements, but also specifically addressing Article 250, which pertains to grounding and bonding. Secondly, a comprehensive assessment of the building's electrical needs is crucial. This includes determining the load requirements, the type of equipment to be used, and the potential hazards present in the environment. Thirdly, a detailed electrical plan should be developed outlining the wiring methods, overcurrent protection, grounding, and bonding techniques to be employed. This plan should be reviewed and approved by a qualified electrical engineer or inspector. Fourthly, the selection of appropriate materials and equipment is essential. This includes using conductors of the correct size and insulation rating, selecting overcurrent protection devices with the appropriate interrupting capacity, and choosing grounding and bonding components that are listed and labeled for their intended use. Fifthly, proper installation techniques must be followed meticulously. This involves ensuring that all connections are made securely and with the correct torque, that conductors are protected from physical damage, and that grounding and bonding conductors are installed in a continuous and uninterrupted manner. Sixthly, thorough testing and inspection are necessary to verify the integrity of the electrical system. This includes performing continuity tests, insulation resistance tests, and ground impedance tests to ensure that the system meets the NEC requirements and is safe for operation. Seventhly, regular maintenance and inspection should be conducted to identify and address any potential problems before they escalate into safety hazards. This includes checking for loose connections, damaged conductors, and corroded grounding and bonding components. By adhering to these steps, one can ensure that the electrical system within a pole building is safe, reliable, and compliant with all applicable codes and regulations. Remember, electricity is a powerful force that demands respect and caution. Neglecting proper electrical practices can have serious consequences, including electrical shock, fire, and property damage. Therefore, it is always best to consult with a qualified electrician or electrical engineer to ensure that electrical work is performed safely and correctly. Furthermore, it is important to document all electrical work performed, including the electrical plan, materials used, and test results. This documentation can be valuable for future reference, maintenance, and troubleshooting. It can also be helpful in demonstrating compliance with codes and regulations. In conclusion, the bonding of sheet metal in a pole building is a critical safety measure that should never be overlooked. By understanding the principles of grounding and bonding, following the NEC guidelines, and consulting with qualified professionals, one can ensure that the electrical system within a pole building is safe, reliable, and compliant. Do not compromise on safety when it comes to electricity. Take the necessary steps to protect yourself, your property, and others from the hazards of electricity.